Hello everyone, and welcome. Have you ever looked at a spectrum and noticed how some colored lines are incredibly bright while others are faint or missing entirely? It's not random. Atoms and molecules are like tiny machines that follow a strict set of rules when they interact with light. Today, we're going to explore these rules, which determine the difference between allowed and forbidden transitions. Let's start with the easy ones, allowed transitions. Think of an electron in an atom moving between energy levels. An allowed transition is the most direct and efficient path it can take. It perfectly obeys a set of guidelines called selection rules. These rules are derived from the principles of quantum mechanics and dictate which jumps are probable. A classic selection rule, for example, states that a specific quantum number, the orbital angular momentum, L, must change by exactly +1 or -1. So, an electron can easily jump from an s orbital, L equals 0, to a p orbital, L equals 1. Because these transitions are so probable, they happen very quickly and frequently. This results in the strong, sharp, and intense lines we see in an absorption or emission spectrum. When you see a very prominent spectral line, you're almost certainly observing an allowed transition. Now, what about forbidden transitions? The name is a bit dramatic. A forbidden transition isn't truly impossible, it's just extremely unlikely. It violates the selection rules. Using our earlier example, an electron trying to jump directly from an s orbital, L equals 0, to a d orbital, L equals 2, would be a forbidden transition because the change in L is 2, not 1. Another common forbidden transition involves an electron changing its spin orientation, which is a key principle behind things that glow in the dark, a process called phosphorescence. Because these transitions have a very, very low probability of occurring, they happen much more slowly and produce incredibly weak spectral lines. In many lab conditions, these lines are so faint they are completely drowned out by the bright, allowed transitions. However, under specific circumstances, like the extremely low-density gas in deep space nebulae where atoms don't collide often, these forbidden transitions have a chance to occur and can be observed, giving astronomers crucial information about the conditions in space. So, in short, allowed transitions are the rule-abiding, high-probability jumps that create strong spectral signals, while forbidden transitions are the rule-bending, low-probability events that create very weak signals but are still a vital part of understanding our universe. Thank you so much for watching and diving into the quantum rules with me. If you found this explanation clear and helpful, please consider supporting the channel. A simple like, a comment, or subscribing helps us grow and create more science content for everyone. Until next time, stay curious.